Hello, everyone. This is Christine Perret. I'm the chair of the AR for Enterprise Alliance Research Committee, and it's my pleasure to be chairing the September 29th webinar on the subject of advanced user evaluation methods, and to have a special guest with me, an expert, to present on this subject. But before we do that, I'd like to tell you that we are recording this webinar, and that those of you who are attending are in listen-only mode. So if you have any questions, please use the question panel in your GoToWebinar app. Mark, would you please advance this slide to the next? Thank you. So I'm just going to start with a few minutes about the area, and then hand it over to Mark, who will introduce himself and tell you more about his activities. And Mark has shared with me, and I'm delighted to say we have more than 30 minutes worth of content. So we will be able to go longer, and then we'll take questions from participants. So Mark, would you please advance to the next slide? So the AR for Enterprise Alliance is an industry association. It's the only global nonprofit industry association dedicated to the advancement of a comprehensive augmented reality ecosystem focusing on enterprises. And that's why we put the enterprises at the top of the pyramid here. They are typically large enterprises in heavy industry, although there's a wide variety of industries that are now using augmented reality, and they tend to be using it for the purpose of improving operations, reducing risk, and other optimization and performance-related goals. The enterprises are supported by providers of technologies, those that offer enabling technology components, full services and systems, software and hardware. There's a wide variety of providers. And I like to say that the providers and the non-commercial entities, such as universities and research institutes, public agencies of all kinds, are supporting both the providers and the enterprises by developing and pushing the boundaries, innovating, and bringing us new technologies. And Mark Billinghurst here today is a classic, a perfect example of someone who has spent his entire career in the non-commercial entities doing just that. So you'll hear more about that. Mark, would you please go to the next slide? So the area is dedicated to accelerating the ecosystem growth, and we do that with these 4 pillars. We provide thought leadership content, and we curate the content of others. And so you'll see area brand coming up in other websites and portals. We do have our own very extensive portal of information, and we provide events like this, and we go to attend and participate in other events. That's where we also support, and we have our own networking infrastructure. We are dedicated to helping people get trained or improve their knowledge and their skills so that they can deploy augmented reality in enterprise environments. And when we we identify barriers to adoption and work together, area members work together to reduce those barriers in a variety of committees, of which the research committee is one, but we also have committees focusing on usability and human factors, safety, security, and other topics. Hope you'll find out more about the area by going to the website. Mark, I think that's my introduction, and now I'd like to turn it over to you. Thank you so much for your support and sharing with us your knowledge about augmented reality.
Great, so I hope you can hear me okay. So as Christine said, my name is Mark.
Perfect.
Perfect, great. So my name is Mark Billinghurst. I am a professor at the University of South Australia and also a professor at the University of Auckland. And so I'm going to talk today about advanced methods for user evaluation in enterprise AR. First of all, though, I'd like to talk to you about where I used to live, which was in Christchurch, New Zealand. So these are some pictures from Christchurch. On the left, Christchurch has the River Avon flowing through it, which is a very beautiful river. And on the right-hand side is the cathedral, which is in the centre of town. So in this February 2011, though, most of you will remember there was a big earthquake, and that devastated the downtown of the city. So this is what the cathedral looked like after the earthquake. You can see on the left the spire has collapsed, and then other buildings in the town had the fronts falling off, and about $30 billion of damage was done to the city. So a huge amount of damage was done to the city. So when that happened, we developed an augmented reality app called City View AR. And this app lets you walk around the city, hold your mobile phone up, and see buildings put back in place that were demolished or being demolished. So in this case, for example, you can see this is taken outside the public library in Christchurch. That was very historical. It's the first public library in New Zealand, built in 1875. And that's just been demolished now because of the earthquake risk. But when you look through your mobile phone, you can see a virtual copy of that building put back in place. So it helps you to see the city as it used to be. So to develop that app, we had to go from an idea to basically a product we could put onto the App Store. And so we started with a list of requirements, and then from there we went to create some rough sketches of what the user interface would be like, and then some wireframe images, and then we built an interactive prototype. We put a more high fidelity prototype, and then at this point now we started coding and we developed the app itself, and then we released the app onto the App Store. So there was a continual cycle of designing, develop, and evaluation. And the other thing was that there was an iteration on this, so we went back to some of these previous steps and changed minds and went around. So this approach is quite common in building enterprise augmented reality applications. And this is typically the interaction design process that people use. And a big part of that process is this evaluation step. So with the interaction design process, the idea is to iterate around these steps of needs analysis, design, prototyping, and then evaluation until you get to the point where you have a product that's ready to be released. So the famous Tog, or Bruce Tognesi, said that interaction design with its repeating cycle of design and testing is the only validated methodology in existence that will consistently produce successful results. And in particular, he says, if you don't have user testing as an integral part of your design process, you're going to throw buckets of money down the drain. So that's what we're going to talk about today, is about user evaluation and testing and how important that is. So first of all, what is evaluation? Well, it's really about collecting data that helps improve the quality and the design of a product. So typically data around user performance, usability, user acceptance, and the user experience. And why do you do that? Well, you do that because you want to keep on refining the prototype solution. You want to also learn more about the user and the problem that you're trying to address. And then if you refer back again to that interaction design cycle, you want to go through the next iteration of the design. And so the more you evaluate, the more times around you can go and produce a better design. So there's people who have different ideas about when evaluation happens. Some people think the evaluations happen once the product's been developed. So you basically do a design phase, an implementation phase, and then an evaluation phase, and then you do some redesign and re-implementation. But other people think you should do the evaluation during design and development. So it looks more like this, where we've got short phases of design and evaluation and redesign and implementation. And so there's pros and cons with both of them. The first one is that if you wait at the end to do your evaluation, you have much faster development, and you may have smaller evaluation costs because you're only doing evaluation once. But the big disadvantage is that it can take a lot of money and time to fix any problems you discover, because by the time you get to do the evaluation, then you've already implemented a lot of the features of the product. If you do the evaluation during design development, it means you can find and verify problems much earlier. Now, with the example I showed you with the mobile AR, City View AR application, we were doing evaluation even once we first started doing the sketches of the interface. So the disadvantage of that, though, is that it can lead to higher evaluation cost, and it could lead to a longer development time. But overall, doing evaluation during the design development will be much safer and lead to a better outcome. So I highly recommend doing that as the process. In general, there are two types of evaluation. There's formative evaluation that starts at early stage of development, and this is really when you've got low fidelity prototypes. And in this case, you're really focusing on the user experience and their perception of the experience. And you may also use this for comparing multiple design options. And then there's also summative testing, and this is where it's done later in the development when you've got a high fidelity interactive prototype. And this is normally done to evaluate the effectiveness of the design choices you've made, and the focus is on performance and usability. So if we return back to our CityView AR application, you can see that the formative evaluation really took place in the first few steps. Once we had the sketching drawn, and when we did the rough prototyping and interactive prototype, that's when we did the formative evaluation. And then once we started building the high fidelity prototyping and the coding, that was when the summative evaluation happened, and they do overlap a little bit. So that kind of shows you the difference in evaluation types. And generally, you typically go from a formative to a summative evaluation, going from looking at the user experience and user perception of the interface and getting some feedback on the overall idea of the interface, through to evaluating the performance of the interface in the summative steps. So in general, there are 4 different evaluation paradigms: quick and dirty, user testing, field studies, and predictive evaluation. We'll go through each of these and talk about them a little bit. So first of all, quick and dirty is where you've got a rough sketched out idea and you want informal feedback from users to confirm that they think the interface has the features they want and it meets their needs. And so you can do this anytime once you've got some sketches on paper. So this is, for example, is the sketches that we had for the CityView AR application. And this was really only a few days after we started thinking about the application. We just quickly sketched stuff on paper, viewed it on a mobile phone, and got some feedback. So the emphasis really for quick and dirty is fast input into the design process. And in this case, we used an application called POP, and POP allows you to take photographs of interface sketches and then link them together with hotspots. So in this video here, you'll see the POP application working. So as I said, you basically just take photographs and then you can load them on your phone, and you can add hotspots that will jump between different scenes. So even though it's just pieces of paper sketched out, I can simulate the interaction with the display. I can click on buttons and have it jump to different things like this. So it's perfect for very quick and dirty prototyping and getting early feedback. So the next topic is around user testing, and this is really crosses into the formative and summative evaluation. And this is much more involved and time-consuming process. It typically involves a deeper evaluation, investigation of the users and their use of the interface. And it's closely related to also topics in behavioral science and ergonomics and human factors as well. So there are many methods you can use for user testing, running also from formative to summative, so ranging from interviewing down through formal user studies. So you can see here at the top, these ones are the more descriptive techniques, and the focus is really on getting subjective feedback about the user experience you're designing. And then when you get to a formal user experiment, that's when it's more about the experimental evaluation and comparing different options in terms of the user interface. So oftentimes people will mix and match these to match their needs when they're trying to build together an evaluation program. So one of the first things people do is do an internet focus group. So basically ask a set of target users for feedback, their ideas around the user interface, and really just record the conversations or get informal feedback from this group of people. It's a very popular and common way to get evaluation input. Another way that's really easy to do is through surveys. And so this is, of course, where people are asked to respond to questionnaires. And surveys are a really great way to get a large number of responses from people and also to capture that big picture really quickly. A really popular survey people use is the Net Promoter Score. So if you've been on the web and bought products from a website, oftentimes you'll be presented with a survey like this, which says how likely are you to recommend this product to a friend or colleague, and pick a number between 1 and 10. And then in this case, it's a bit more fancy because it asks you also to provide some written feedback as well. So the Net Promoter Score is a standardized measure across a large number of industries, and they can look at the score you give and compare it to other industries. And the way it works is they look at the top 2 scores, 9s and 10s, and they look at the percentage of 9s and 10s subtract it, and then subtract from that percentage of 6 or below is the detractors, they call it. And this provides you with an overall score. And then on the right-hand side, you can see a list of different industries with their net promoter scores. So specialty shops in the US have an average score of 62%, whereas cable TV has an average score of 1%. Nobody likes the cable TV providers. So what you can do is you can do this for your particular product, and then you can compare where your product sits compared to the industry average for your industry. So it's a very popular way. It's a very simple example of a survey question. One of the more time-consuming things is doing a formal experimental study. Oops, sorry. And this is where you typically try and explore a comparison between 2 or more conditions in the user interface or the application. So you have some independent variables, and these are the variables that you're manipulating to try and create different experimental conditions. And the dependent variables is the measures that you measure to find out the result of that manipulation. So for example, you might look at the size of buttons on the screen. That would be your independent variable, and your dependent variable might be how fast it takes people to select the buttons. You know, obviously the bigger buttons will take less time to select them. So when you're designing this type of experiment, you have to decide if you want to do a between subjects or within subject experiment. Between subject experiment means that each person taking part in the experiment only gets to experience one of the conditions. So people come in, you randomly assign them to one condition, and then you collect their data and do some analysis. If you're doing a within subject study, then each person experiences all the conditions. And in addition to that, you also have to randomize or counterbalance the order of the conditions. So there's pros and cons doing within subjects. Great because you can remove differences between individual differences. You know, if you've got a study that relies on people's spatial ability, you may have 1 or 2 subjects that are very good at spatial ability, and they could skew the result. So within subjects where all the subjects do all the conditions, removes that. But there can be some disadvantages where you might have a learning effect, where if you put them multiple times into the computer interface, they may learn how to use it. The between subjects may be sometimes faster because you only have one condition to explore, and but they do also require a larger sample size. So there's pros and cons for both. Once you have running the experiment, you have to also collect some experimental measures, and these can be generally broken down into objective or subjective measures. So objective measures are ones that aren't influenced by the personal feelings or opinions. So they, whereas subjective measures be based upon the user's opinions. So for example, performance in performing a task would be an objective measure, and the user's opinion about how easy it was to use an interface would be a subjective measure. So here's an example of several objective and subjective measures. You can see in this case a subjective measure, we've got a Likert scale going from 1 to 5, where they can rank how easy the task was. And the objective measure at the bottom here, this is a performance measure. So here's a graph here showing that the time it took to perform a task is related to this log on the bottom. And so common performance measures are performance times, accuracy, and errors. So when you're designing an experiment, you have to think about what are the subjective and objective measures and the qualitative and quantitative measures here. There are also, there are also standard questions you can ask as well. So there's a wide range of standard questionnaires that you can add that have been validated in the human-computer interface field. Things like the system usability scale, which is used to evaluate the usability of the system, or the NASA TLX scale, which is used to evaluate the workload. So if you're designing an experiment, then I highly recommend you looking at what standardized measures or questionnaires you can use that have all been validated, and then that adds a lot more validity to your experiment. The third type of studies are field studies, and these are ones typically done in natural settings. So you want to look at how people use a technology in its desired end point. So for example, if you're developing a mobile AR app, like the app we did for the earthquakes, then at some point you want to take it outside and have people use it out in the real city and get feedback from them. And this is also important because you might by observing how people use the technology, you might discover some opportunities for new uses of the technology, or how you can change it to create new interface features as well. So a nice example of that is this research paper that was published about 10 years ago, and this was looking at a comparison between how people use digital maps to an augmented reality enhanced map. So you can see on the left-hand side, there's a digital map that appears on the mobile phone, and the AR enhanced map, they had a real map, and when you held your phone over it, you get an AR tag appearing that would show the same information as what's on the digital map. But they really want to see how people would use this out in the real world. So they gave people both of these applications, and they had people go out in pairs and navigate around a city using the map. And then an experimenter would follow behind them and make some observations. And so on the right-hand side, some interesting examples of uses. They found, for example, that when people used the real map, they would point at the real map to provide some guidance, and both people would be looking at the real map. But when you had the digital map, one person would hold the digital map on their phone and somebody else would have a paper map, and they'd oftentimes look at two separate objects. They wouldn't look at the same shared object. And you can also see, in fact, that on the second picture there, you can see both people looking at the mobile phone to see the AR enhancement on the AR map. On the digital map on the right-hand side, they're looking at separate objects as well. So there was a big trend towards, in the AR condition, to people using the map as a shared artifact, whereas in the digital condition, they would use the raw map as a different artifact. So that's the type of user feedback you can get by observing people using the technology in a natural setting. The final type of study is a predictive evaluation, and in this case, you ask experts to apply their knowledge of users, guided by some specific heuristics, to predict usability problems in the interface. So there are many different heuristics available. Jacob Nielsen has his 10 principles of user interface design, and Bruce Tognesi has 16 principles, and Ben Snyderman has a book, and Don Norman has his set of design principles. So you can take these design principles and then you can look at the user interface and you can find areas where you think it should be changed or improved. And a key feature of this is that real users don't need to be present, which means that this can be very quick and inexpensive. You could get an interface expert to come along and you look at your user interface and within a few hours identify many of the problems with it. So one of the questions is how many experts you need, and Jacob Nielsen says that if you have 5 people looking at your user experience, then they should be able to identify 80% of the problems in the system. It depends a little bit how complicated your system is, but that's a pretty good number. So you can see it could be relatively fast to do that and also relatively inexpensive. So that's an example of the types of evaluations you can do. I want to drill down and give you a bit more complicated example now of a user study we've done ourselves. And this study was looking at how you could build a collaborative interface between an AR and a VR user. It's a little bit like what we have now with Microsoft HoloLens, with the remote assist, where you can take the view from the HoloLens and you can share it with a remote person who's trying to help you on a task. But in this case, the remote person is going to be in VR, and they're going to be in a copy of the world that you're in. So both people are sharing the same environment. And we were really curious about what might be the effect of gaze cues in this situation. So we had the setup here. We had one person with AR, one person in VR. They both had hand tracking technology, and then in the AR or VR display, they would see the other person as a pink head and with their hands as well. And then in addition to that, you can see on the pictures here, in some of the conditions, there was a pink pyramid appearing out of the person's head, or a gaze line as well. And this was supposed to provide a communication cue about where the person was looking. So the overall experiment was designed to explore how having this gaze cue could impact the collaboration. So we had 4 conditions: a baseline condition where we only showed people's heads and hands, a field of view condition where there was a pink pyramid shown, and then a head gaze condition where you had the pink pyramid, plus you had a gaze ray that was attached to the head pose, and then an eye gaze condition where you had the pink pyramid, plus you had the eye gaze rays as well. And then we had people do a collaborative task. So both people were either they would see each other either both in the AR or the VR condition. And then around them, there were these blocks. And for one person, the blocks had numbers on it. and for the other person, the blocks had letters on it. And the goal was to try and find the block with a specific number-letter combination. So they had to communicate together. When they found that block, they would pick it up and put it in a special location. So this was designed to force collaboration. It was also within subjects design, which means that everybody got to experience all four conditions. So here's a video of the system working. You can see now in the AR view, I can see my collaborator and this pink pyramid coming out of his face. This is now the VR view. Again, my collaborator with the pyramid. And the main thing about this pyramid, of course, is that you can see where the person's looking, even though you can't see their face anymore. So you can see now, I can see out of the corner of my eye the pyramid. Now the person's face is coming into view, and we can collaborate together to try and find these blocks. So that was the basic experiment. You can see we had people do the task in the same room, but there was a curtain between them, so they couldn't see each other, but they could talk to each other and collaborate quite easily in the system. And in terms of experiment measures, again, we had to think about objective and subjective measures. So we had a number of performance measures, including the task completion time, how often they both looked in the same direction. The observed measures were the number of hand gestures people made, how much movement they made. And then we had subjective measures around the system usability scale. And also we had a social presence survey where they could say how much they felt the other person was really with them in the space. And then after that, we also interviewed both people as well. And we had 32 people, so 16 pairs. Most of them had no experience with VR or AR. Then we collected on the objective data 512 data points and subjective data 128 data points. And this is what some of the data looked like. It's not important to remember this, of course, but just gives you an idea of the diversity of data we get. So you can see these top two rows are all around survey data. So questions around ease of use and usefulness, and giving a response on 1 to 7, and then the social presence and the communication scores. And the bottom row is around how often people looked in the same direction or used gestures and pointed as well. The other most interesting thing we probably collected was also looking at people's motion data. So these heat maps here showed how much people moved. And in general, you can see the VR map at the bottom, the contours are a little bit bigger than the AR map. So people in VR generally walked around a little bit more than people in AR. And so we did some statistical analysis and these results, and we basically found that having either head or eye pointing produced much better performance than having no cues at all, and also reduced the need for pointing. So in the baseline condition, when you couldn't see the other person's gaze cue, you would often have the other person pointing and you could see where their hand was pointing. There was no difference in the task completion time, but there was a big impact on the mutual gaze and also the co-presence scores as well. There was also no difference between head gaze and eye gaze, which shows that if you've got a head pointer attached to your avatar, that might be just as good as having a eye gaze pointer. So some of the lessons that we learned from that was it's very important to decide on the type of experiment you're going to do before you start the experiment, of course, and have a well-designed task with good experiment measures. We use both objective and or qualitative and quantitative measures, which is also important. We need to have enough subjects for significant results and use the appropriate statistics, and then also provide some training and observe users' behavior. So I want to talk now a little bit about how you can go beyond questionnaires. So a lot of user studies that people do in enterprise VR and other settings, they use a lot of questionnaires, whether it's Net Promoter Score or usability questionnaires. But now we've got technology that allows us to go beyond that. On a number of ways. First of all, we need to consider the entire user. We can move data capture from questionnaires captured at the end of the experiment to capturing data through the experiment. We can capture a wider range of data like physiological cues or behavioral cues, and also map this to a higher level of understanding. And there's a lot better tools out there as well. So I'll talk about a couple of these things. First of all, it's really important when you're doing evaluation to consider the whole user. So in the study I just showed you, we're really measuring people's ability to physically perform a task. So we're looking at the physical and the cognitive aspects, but we really didn't measure very much about the cultural or the emotional aspects. And a really interesting survey that was done about 5 years ago in the US found that of the people surveyed, only 12% of the 4,500 adults surveyed would want to wear augmented reality glasses because they're worried about them looking silly. And they also surveyed people who'd used mobile AR applications, like you can see on the person on the right here, holding a tablet up looking at a museum artwork, and seeing some AR overlays, and they found that 20% of those people had experienced some social issues. For example, when you hold your phone up like that, people may think you're filming them rather than looking at AR content. So to some extent, acceptance of AR in the enterprise space is more due to social than technical issues. A lot of technical issues have been solved, but there's a lot of social issues that need to be studied more. So for example, this is a project done about 5 years ago by a company called TAT, and they had the idea that it would be really nice to be able to tag people in the real world with some of their social media content. So the idea was you'd be in a meeting and you'd hold your phone up and look at somebody through the phone, and as you see in the middle, you'd see these tags appearing around them with links to LinkedIn or to your business card or other things like that. So that sounds like a really great idea, and you know, I know I'd find that really useful because I'm always forgetting people's names. But if you think about how it would really be used in a social setting, you find out that it may not be such a great idea. You can imagine you're in a business meeting with some strangers, and somebody opposite you on the table pulls out their phone and starts pointing it at you and filming you. You know, how would that make you feel? So people who thought about that said, well, it may make you feel like you've been stopped by the police for ID or security scanned. And somebody else said that anybody pointing a device in my direction to try to identify me better be prepared for either a lawsuit or a punch in the face. So you can see, even though technically we can do these things, when you start thinking about the social implications of them, it means that they may not be such a great idea, or you may need to evaluate more around the social aspects. Another important thing to evaluate around is the physical ergonomics. So especially with augmented reality, where people are doing actions in the real world, you may, for example, want to look at ergonomics for hand input. So there are many examples of augmented reality interfaces where you've got floating menus around you. So one question is, where do you put the menus so people can easily interact with them? And you may end up having what's called the gorilla arm problem. So here's a person you can see using Microsoft HoloLens, tapping on a virtual menu. And if you have to hold your hand in space for a long period of time, you start getting tired. So the design on the left, design A, shows a typical AR interface designed for interacting with objects with hands. But design B is actually better because you can now hold your hand at waist height and it's more relaxed and less tiring and still interact. So you manage to evaluate that, and there are some tools that can help with this. There's a really interesting piece of software that was just released this year called Exergonomics, and the idea is it uses a physiological model to calculate the ergonomic interaction cost of reaching certain places around the body. So this allows you to model the fatigue or how much effort will be involved to select certain regions around your body and know where you should put the interface elements. So this is actually an open source tool, there's a repository there, and here's a little video of the system working.
Users can experience discomfort or even injuries due to prolonged midair interaction with 3D user interfaces and unusual moving patterns. With Exergonomics, we aim to make existing methods.
Mark, the sound on that video is very low, but it's okay.
Oh, okay.
We can understand. If you can narrate it, that's probably better.
Oh, I'm sorry about the sound. So basically, they were just showing how that they had this interface, so you could go and you could adjust a virtual person to match your body size, and then it would show around the person's body the amount of effort it would take to interact with content at those locations. And then they had a HoloLens application at the end where it would actually automatically place interface elements in the regions of least effort. So this type of tool is the type of tool we need to do more of a physical ergonomic evaluation. There are also new tools we can be using as well, and particularly using new types of sensors like EEG or ECG and GSR, and through that measure things like stress and emotion and cognitive load. And most excitingly, these sensors are being integrated into the VR and AR displays now. So a good example of that is the Hewlett-Packard Omniset display. And this is a display that has just come on the market in May this year. It has a wide field of view, high resolution display. So it's typically very good for a consumer VR display. But most interestingly, it has eye tracking integrated into the display, and also pupillometry and heart rate, so it can measure your heart rate information, and has a face camera, so it can measure your face expression. And they also ship it with a developer kit where you can measure cognitive load. So this is the type of system you want to use if you're doing, for example, training applications, and you want to measure people's stress or cognitive load while training. So I've got a small video of this one. I'll put the audio up, and hopefully you can hear better. Okay, let's play it again.
Technology shouldn't just exist for technology's sake. It should create safer workforces, better workforces, more efficient processes. We offer a range of different virtual reality training experiences for particularly high impact industries such as construction or manufacturing, public safety. One of the things that's critical in training generally is the ability to provide real-time feedback to someone so that they can know in the moment what they did wrong, what they were experiencing, so that they can make those adjustments. Omniset really expands the value of what we're able to offer to get a more complete picture of what's possible in extended reality and what's possible within their own individual workforce.
With PixelVR and HP Omniset, we're really creating compelling content that can save lives. We can use the eye tracking to do volumetric heat mapping of where they're looking. We can use the active HP Omniset bioanalytics data to really see what type of performance their employees have.
Being able to really accurately demonstrate that ROI picture for a client, you have to really offer them something compelling. Omniset helps us make that case much more effectively. We're able to say this is not just a building a better mousetrap, right? This is qualitatively and quantitatively better training.
We found the developer portal to be really the first place to start with HP Omniset. They already provided a native plugin for our chosen engine, which is the Unreal Engine. So integration was actually quite simple.
The sky is the limit for what it can possibly bring to the larger picture of training and beyond. HP has been right there with us the whole time, and it's been a very positive experience for us.
Okay, so that's the Omniset with their physiological sensing, and you can see with that, as they talked about in that video, how they can use that to enhance training. So of course it's a VR application, but similar capabilities are now coming to AR as well. And this kind of diagram here shows how it works, where you've got a range of sensor data that's pulled off the headset, and you can connect that directly into your VR or AR application, and then have also with the Omniset SDK, you can measure the cognitive load and other stress and other information from that data as well. There are other devices as well. This is from a company called Lucid, and Lucid sells some EEG sensors that will fit into the faceplate of a VR display. So you can measure brain activity while you're inside VR. But of course, once you've got all that data coming off, you need somewhere to analyze it. And on the web, we oftentimes use web analytics tools that can measure the where we're clicking and create heat maps of where we're interacting with the websites. Well, the same thing can be done in VR, and so this is a tool from a company called Cognitive 3D, and they provide analytics for VR. So they take the raw data input, the eye tracking, the heart rate, EEG, and then they create a tool that can visualize that back into the interface. So you can see here on the right-hand side some heat maps overlaid onto the VR environment, showing the people mostly interact inside the VR. And they can do the same thing for AR as well. So this video here shows an example of that working. So what you'll see is a AR kit application, AR application where they've got a virtual cabinet on the wall here. You can put a little survey in the real world, and then you can answer some questions about the experience you just had. And then as they walk down the hallway, they can walk down and look at into the cabinet and check to see whether the breaker has been activated in that. And then at the same time, the system records all their actions in the real world and it allows you to play it back later. So now you can see in the dashboard here, you can see the actual motion of the person in the real world and where they were looking at that virtual cabinet. And there's more analytics data you can get as well, like gaze time and how long they engage with the object and things like that. So these are the types of tools we need to be able to process all that rich data coming from those physiological sensors. And to give you an example of the type of study you can do with that, this is a study we did a year ago looking at how we can measure trust. And so there are some subjective surveys of trust you can use, but in this case we want to look at how we could add other sensor inputs, EEG and GSR and heart rate variability, to see if we can use those sensors to infer trust. So the person here is wearing a VR headset. They've got an EEG cap on their head as well, and on their hand they've got a shimmer device which measures the heart rate and the sweat level. So in this case, they had a task where they had to look around it and try and find objects in the virtual world. But in some of the conditions, they would have an agent that would tell them which way to turn to find the object. But sometimes the agent was telling the truth and sometimes it wasn't. So we want to look at, if the person was using an agent that was 100% accurate, then we would assume that they would have a high level of trust. If they're using an agent that was very inaccurate, half the time inaccurate, then their trust level will be a lot lower. And can we detect that by using logical sensors? And this is important because if you're using, a self-driving car or some other piece of technology that uses an agent to provide feedback to you, you want to know how much the person trusts what's coming, and if we can use sensors to infer that trust. So we did that. We had, as I said, 3 conditions where an agent was low accurate, high accurate, and there was no agent at all. And we also had a task which caused cognitive load to happen on the brain. So we looked at what happens when you're in a high cognitive load or low cognitive load situation. We measured, as I said before, some physiological measures, EEG and star. We also looked at the performance time and accuracy, and also some subjective measures, including trust survey. And what we found actually is that from the EEG signal, we could look at the power of the signal using a fast Fourier transform, and there was a peak that occurred when you had the most trustworthiness. You can see on that, it's hard to see, but on the top right-hand graph, there's a green line, a red line, and a blue line, and the blue line is the one that is most trustworthy and has the highest peak. So overall, we found that by using a combination of sensors of physiological performance and subjective measures, we could detect quite accurately how much trust people had for that agent character. And so this is the type of experiment you can do once you've got that physiological measures. So I just want to finish up, running over time now, just a couple of comments about research directions. And so last year, or actually, sorry, 2 years ago, we published a paper where we reviewed 10 years of augmented reality usability studies. So if you're interested in AR studies, I highly recommend you reading this paper. And from this paper, we found a number of interesting things. First of all, we found that most augmented reality papers actually don't have a user study in them. So the graph on the left here on the bars there show the total number of papers being published. So 2014, there were almost 1,500 papers published. And then on the right-hand side is the percentage of papers which have a user study in them, and you can see it's kind of maxing out at about 10%. So it's not a lot. We also looked at how there's a change in trends over time over the displays that we use in studies, and also the type of experiment types that were being done. So you can see here on the right-hand side the type of studies, and by and large, the bulk of the studies in blue there are formal user studies. There are very few field tests, so you can see a smaller green line, and almost no heuristic studies, that very small purple line there as well. And then on the right-hand side, the left-hand side, sorry, it talks about the type of studies that were done. And you can see, for example, there were almost no studies done that were collaborative studies, but quite a lot of studies done in interaction and in the education space. And we have some other tables that talked about the average size of subjects that are in the pool and the numbers of studies that use different display conditions and so forth. So I won't go through all of that, but I highly recommend you read the paper. Some of the high-level things we found was, again, that we had very few formal experiments. Most used a within subjects design and mostly in controlled environments like a lab. And only half of them used a mixture of qualitative and quantitative measures. And mostly they use young university students as their subjects, which is a worry because, of course, for enterprise applications, there's a much wider range of users. And there was a pretty even split between head-mounted and handheld displays. But so from this is a lot of opportunities for research. Work needs to be done on increasing user studies and collaboration, more studies on outdoor and interaction, a wider range of evaluation methods, more diversity in participants and large numbers of participants, and a wider range of demographics and so forth. So just to wrap up, today I've talked about how you need to evaluate throughout the design process, and generally you need to move from a formative evaluation, which is quick and dirty, to more summative evaluation where you're looking at performance. It's good to use multiple types of evaluation and multiple types of data, And now we can go beyond questionnaires and use things like sensors to collect raw data of heart rate while performing a task, or looking at other types of elements of the user study, like the cultural or social factors. And there are many, many directions for future research. So really, there's a lot more work needs to be done in the AR space about how to design better studies. And if this topic really interests you, this is a really fantastic book that talks about research methods, and it talks all about how to design studies, not specific for augmented reality, but in general. And they produce a taxonomy of a wide range of different studies. So here's 20 or 25 or so different types of studies you can run, and the book tells you all about how to do that. So that's everything I want to say for now. Here's my contact details. I'm certainly happy to send you copies of the slides if you like. And I know this is being recorded, so you can watch this again some other time. So thank you very much for your time, and I'm happy to take some questions now if there are any questions.
Thank you, Mark. This is fascinating. I mean, for me, it confirms so many of my doubts. We're really working blind, it seems to me. One of the questions I have is, you've been working in this field. Where is the funding going to come from to perform? Like, you had those future research directions slide, those bullets. I would really like to include those in our research agenda. We have a few topics, that maybe 3 or 4, that are on user interaction study, and we could certainly add more. But the problem is also always going to be funding these research projects. It's expensive to conduct the type of research that you're proposing.
Yeah, well, there's a couple of things. So first of all, if you're a company like Facebook, then there could be some serious health implications for some of the AR and VR interfaces that they're developing. And so it's in your own interest to do those studies, because otherwise, if you release a headset that causes problems for people's eyes, or somebody's using it and gets distracted and has an accident, then there may be some legal consequences for you. So for companies that are working in the space, there's a certain amount of studies that they need to do from a health and safety perspective. Then there are also studies you need to do for from a validation perspective. So, for example, if I'm using the Hewlett-Packard Omniset interface in my VR training system, and I want to try and sell it to somebody, they're going to ask, well, how much better is it to use this system than using another training system that doesn't have this eye gaze and heart rate in it? So if I can then point to a study and say, well, we found a 30% improvement in performance, then that. So those types of things are in people's in the interest of business to do that. But then there are a whole other category of studies that people explore because they're exploring more fundamental issues that may not be funded by business, but oftentimes can be funded through government or other research agencies. So things like, for example, well, actually doing research on the best types of studies to design, and can you come up with a design process for AR and VR studies. It may be difficult for companies to fund that, but you may be able to get some funding from government agencies, or doing studies on things like social neuroscience in AR that may not have a commercial application for decades, but may have some very interesting lessons that could be learned about fundamental neuroscience. So those are funding sources, I would say, that can be explored.
But I'm a member of the Underwriters Lab, UL STP 8400 experts group, and indeed, as you said, the hardware manufacturers, to my knowledge, all of them are participating in the development of a standard and methods for testing those issues that could cause harm or that could interfere with people's perception of the real world.
Yes.
And another question that I think people in enterprise really need to think about is the design of the objects. It's you have to use real people who have those roles, but one of the very early performance measuring studies that was done by Boeing used they were trying to figure out the performance improvements or gains that they could have with AR in wing assembly, and they created a fictitious task. Do you have any insights into the kinds of objects, if they're big or small, or guidance about the task creation itself when you're
That's a really great question. And so there is a lot of work being done with that, especially in augmented reality, because there's a connection between the virtual objects and oftentimes physical objects. And so when you're designing AR interfaces, you have to think about not only the virtual object design, but also to some extent the physical object design. And so there's been a lot of work done around design affordances, and then also how to evaluate those interfaces from a design perspective and an aesthetic perspective. And that's a lot more challenging sometimes to evaluate. If you're looking at performance, you can measure people's performance using over time, but it's much harder to measure the impact on performance of good and bad design. So
yes,
but that really crosses into the industrial design area, which I think is a really interesting area to be working in.
It really is. Thank you for sharing those insights. I think it's very task dependent, right? It's very use case specific. So if you're asking somebody to repair a room-sized object versus something that's microscopic, of course, you're going to want to have the physical object be as close as possible to the. But most of us are working or would like to have user experiences that are generalizable, that use principles that can be applied as easily to a microscopic object as a room-sized object. And that's very, very difficult. I want to thank you very much, Mark, for your excellent contributions and very, very interesting subject. I'm sure people will be following up with you and be able to get more information. And I guess one last question from Victor was about whether there's adoption of XR solutions in New Zealand. So that's a good place to end it, I think.
Yeah.
Tell us about it.
Well, certainly there's actually quite a growing community of XR companies and developers in New Zealand. We had a conference in December last year, and we identified about 85 companies in New Zealand doing XR and VR development, and some of the multinationals are operating here. So, for example, Magic Leap, until a year or so ago when they downsized, they had a group of XR developers in New Zealand that were building some of the games for them, and Apple had a group of developers in New Zealand as well. Certainly there's a lot of research and development going on here. Most of the companies seem to be small companies, as you might expect, but some of them are making a big impact in the world despite their small size. So I would encourage you to come down to New Zealand and see what we've got. In fact, in March next year, in 2022, we have the IEEE VR conference, which is the main research academic VR conference, and that'll be held in New Zealand. So yeah, it'll be about 400 people or so in the country and about 1,000 or 1,500 online. So if you want to, you can come and visit and explore and discover for yourself the AR and VR work going on here.
That's a great invitation. Thank you, Mark. Thank you, everybody.
Great.
And
thank you for your time.
Yes, fantastic. Goodbye.
Great. Thanks so much. Bye-bye.